As you can see from my title, I will choose a particular view on what we call an error. And I come from a field that is called Science and Technology Studies, which actually looks into how societal change and scientific and technological change go together and shape each other. And I think in that sense, it's interesting to ask how error actually has changed over time. This is definitely not a stable category. So what was counted as an error, or what is counted as an error today, was actually not necessarily an error at any given points in time. So that makes it interesting how we look at historical cases, because very often we look at historical cases with the lens from today's knowledge, and then we interpret them and say, okay, they did this kind of error or that kind of error. But of course we would have to creep into the mindset of the time and really understand why something was an error. Now, the second thing I wanted to start by saying is that Michael in the beginning showed a map. And I find it interesting when you look at old maps, and that is a parallel, you have very different kinds of maps. And what I like particularly in, let's say, 18th century, 17th, 18th century maps and earlier, you have maps that don't only show the territory, but these maps show the people that live on the territory. Sometimes they show monsters in the sea to show the problem areas that are identified. So you have a much more graphic imagination of how the world looks like. Now, science has cleaned that up in a perfect manner. Monsters have no place anymore, and also the way how we draw maps is a very physical imagination of space and distance matters. And I think that's an important thing. Now, I come from a 3 days row of talking about trust, about talking about error today, yesterday on trust, today on error, and tomorrow on research integrity. And that made me think about why we are so concerned about that. And that gave me my subtitle of my talk, The Future Perfect Tense. So is it not that we think that science and technology can make this perfect future realizable? Isn't that still the dream? I mean, we don't maybe make it so explicit anymore than we did it maybe 50 or 100 years ago, but it's still this belief that if we do science well enough, it will lead us to a better world, a different one, a full understanding of, etc. At the same time, if you would go into history and you would see how one imagined the year 2000, you would learn that definitely doesn't work very well. Okay, so starting from there, I would like to share some ideas with you. Some of that has already been picked up. That's always when you speak as number 5 out of a row. Others haven't. And, okay, I would like to start with these 3 images. These 3 images depict why we are so concerned with error. The first is science seems to be under observation from a whole layer of things. It's under scrutiny by government, it's under scrutiny by politics, it's under scrutiny by media, and I do think that's an interesting observation. So why do we need to pretend that we are flawless? We have never been flawless, but now we have to somehow pretend that we are flawless in order to kind of keep a certain authority over explanatory power in our contemporary societies. The second does the same thing. So is our system ill? Does it have, I mean, if we cannot reproduce our results, what does that tell us? If we think we have more fraud cases, what does that tell us? And I think that brings this nice big brother image that is from the journal Science, which speaks to the ethical reviews and that we need institutional surveillance of science so that scientists still continue to behave in an ethical way. Now, that opens the second kind of problem. What counts as ethical at a given point in time? And I come from Vienna, so Vienna was leading in medicine at the beginning of the 20th century, and we did all kinds of very strange experiments. I came across some historical documents showing that there were kidney transplantation and in order to not with terminally ill people, and so they transplanted the kidney into the arm of the patient to better watch what's going on in this kidney. I'm sure there was no informed consent or anything going on. One was thinking that was for the good of science that this happens. And we thought that was totally okay, probably. And there was not a lot of questioning about that. We would question that highly today. So these kinds of values have shifted quite considerably. But we also have to think about how we imagine the society we live in. And I do think, if that works, that we have two different kinds of overlapping imaginations. One is that we think society improves with innovation. That is politically a very strong discourse that is here. So we need the new, and everybody needs to pretend that what he or she is doing is totally new, even though it's most of the time not that new. And this, of course, has an influence how we imagine future developments. They come through innovation. And we all live along these promises which tell us where we will move if we are ready to go along that line, even if it looks a bit shaky. And I come at the end of my talk to something of that. And the other part is that we live in a society of self-experimentation. We always have lived in societies of self-experimentation, but we more consciously ask people to engage in that. So to pick up new things, even if it's unclear where they will lead us. We say, new technologies, artificial intelligence, just go ahead. Don't be against progress. This is where we will head on. So we ask people to be experimental, and experimental always means trial and error. So there is a kind of considerable possibility that there will be errors in what we kind of implement and make. And that's an interesting reflection how we deal with that. Now, let me start to think a bit, and that has already been mentioned. Error means go astray, losing one's way, etc. So it fundamentally comes from the word errare. And I think it's important to keep that in mind, but it changed the meaning over time. And I just took 3 time points. While around 1300, it was kind of pictured that the deviation from truth made through ignorance or inadvertence. 100 years later, you find definitions of deviation from what is regarded as normal, which is yet another thing. So normal means somebody has to define what the norm is and the deviation. And in 1726, it suddenly appears with the sciences as an organized knowledge system that it's a difference between observed value and true value. And now we have still truth in all that. That makes it not easier. So, and actually when we speak today, we speak all about trial and error. And there's not a lot of thought about what error means in that and how much error should be allowed or not allowed in the trial. We speak also of risk-taking in research. So how do these things go together, and what is an admittedly allowed error and what does count as not one? So what we have to look at and think about and exchange over is that with the institutionalization of research, so with the fact that we have funded research institutions, we also invent this idea that they should be governed by norms and values. This is not something, when you had individual researchers, that was not something that was necessarily thought about. And these norms and values are, of course, changing with time. In a globalized research system, there are tensions. I mean, just look at the way we discuss what is allowed in some countries or not allowed in other countries when it comes to ethical standards in research. It's field specific. So if I come from the social sciences, interpretative sciences work very differently to what we just have seen, nanosciences or cancer research or whatever, physics, whatever you take. We have to think about the culture of research and critique as a central element. Then, of course, the word of serendipity hasn't come up. That is a much beloved word, that actually we live from serendipity, from the fact that things just happen without our doing, but that we need to be prepared to kind of see the unexpected. And that's, I think, an important point to make. Now, if we take together all these classifications, we have error, and on the one hand, we spoke about uncertainty, we spoke about the honest error, whatever that exactly means. We spoke about lack of precision. We spoke about systemic or systematic errors. But I could also ask something like too fast publishing. We haven't spoken about the real conditions of research, that scientists go out and publish stuff that is not actually checked and balanced, because it's good for their career, it might be potentially interesting. That comes back to what you took as an example, the cold fusion. Actually, one of the big problems of the cold fusion was not only that they didn't make the checks and balances, they first went for a press conference, and then they tried to publish something, and that made the whole thing explode. But before even anything was checked, they already had the media present telling this wonderful story about energy out of nothing. And then on the other side, you have a lack of reproducibility. You have all the debates about fraud, fabrication, and falsification. You have the question of bias. And of course, we all have bias, but what is an acceptable bias then? So, I mean, in medicine, for example, and in biology very long, we did experiments mainly with male animals. Then they went into the clinic and they made experiments with male patients because it was easier, because science was more precise if you just took one category. And women have these strange hormonal cycles and stuff like that. That disturbs the accuracy of science. So we test on male animals, on male humans, and then we give it to females as a treatment. And then some die of it. I mean, yeah, that was an error. Honest. Was it? Okay, so bias. And that is really important when you go into medicine about false positive and negative results, because that matters to humans. And I think there becomes, and I think that has been pulled up already. So what we see here is enormous work, boundary work going on. What is still an acceptable bias and what not? How we are humans as researchers, so there is bias. The question is like, do we reflect it? Now, I just browse over that. There is a huge amount of debates about show me where your money comes from, the problems of that we need to embellish and promise all kinds of things. We have the reproducibility crisis. We have the complexity of experimental animism, and this is very nice, a paper about when mice mislead, which I like very much as a title, because I think, I'm not sure that the mice mislead here anything, but they're complex, and that leads that they don't always comply. Now that brings me to my last point, which I would like to invite you to think about, namely new challenges we are facing right now with this idea of data sciences, where we think the more data we have and the better algorithms we develop, the more we will understand the world. And I think we need to reflect what seeing and thinking the world through numbers actually means and through big numbers means. We always thought the world through numbers, but through big numbers. And I think to collect, store, retrieve, analyze, and present data through various methods means to bring the objects and the subjects that data speak into being. So they are not just out there. Data make what we see in the world. So we just do not see what is in the world, but we make what we see. And the telescope example was a wonderful one, because it's a highly technical reconstruction of images. You don't simply see these things. It asks the whole science of seeing. So it's highly technically mediated through the use of huge amounts of data and reconstructive methods. So we just don't see straightforwardly by any means, and we have to ask what that means. And that brings me to my last point. We are in the middle of an algorithmic euphoria, that we think that algorithms are better than humans. AI and other things bring us and say humans make these errors and other systems don't do that. Now we have to think what we trade it for. And I do think algorithms have the capacity to shape social and cultural formations in the future and impact directly our individual lives. It's not just about knowing, it's about being in the world. So they denote the new rules of rationality that replace, to a certain degree, the self-critical judgments of reason. And because we don't understand algorithms to a certain degree, or we have not developed an algorithmic literacy as a society, this is a very moment where we have to ask these kinds of questions about errors or non-errors and what kinds of lines do we walk across knowledge. Thank you.